Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper. I'm a postdoctoral researcher currently at the Helsinki Institute of Physics over in the University of Helsinki in Finland. I'm stumbling on my intro today. So hello everybody, my name is Diana Hooper, just redoing it. I'm a theoretical physicist working as a postdoc at the Helsinki Institute of Physics in Finland, and I study cosmology, which means I study the universe, the contents of the universe, cool stuff happening inside the universe, early universe, medium-sized universe. It's a very cool topic. I love being a cosmologist, and I love chatting to everybody about all of the really, really, really cool stuff happening inside the universe. So, as always, hello to all of the regulars coming in. I see we already have, let's go. So we have Ange, we have David, we have Paul, we have Scott, the other David as well, Ben. Great to see everybody coming in as always. And for any first-time viewers here, welcome. Great to have everybody here. Now, as always, this is an interactive stream. So the idea here is that you can ask me anything you want about basically anything you want to ask me, ideally cosmology or physics related or academia. You can also ask me about myself. You can ask me random things and see if I know the answer. I do know some random facts. So this is an ask me anything. The idea is you can ask me literally anything. If you haven't done so yet, please do all of the usual YouTube things. Ring the bell, click the notification button, subscribe, leave a comment, like the video, share the video. You know how YouTube works. Press all the buttons, make stuff happen. On that note, if anybody saw my loading screen today of like Cup of Cosmology starting soon, could anyone tell me if you could hear music playing? Because I found a new button that lets me play music, and I have no idea if this is just like chill music for me to listen to, or if you can hear the music as well. In fact, let's just do a quick test. Please let me know if you hear the music that is not yet playing in the background. That should now be playing in the background, because I have no idea if this music is just like for me, or if this music is for everyone. So please let me know if there's some like chill. There is music, awesome. So that's a new button. I can't upload my own music, but I can now have calming music, like elevator music while you wait on the loading screen. That is good. Always good to press random buttons and see what happens. I love pressing random buttons. It's always cool. And today a music button appeared, so of course I'm going to press the one music button. Great to hear that people can hear the music as well. Hey Brett, great to see you as well. Great to see all of the regulars coming in here. Okay, so as always, you can ask me anything you want and I will do my best to answer. Now, I don't have a specific topic prepared today, so we can talk about basically anything. If you want to know about some of my favorite things in the universe, you could, for an example, ask me about the cosmic microwave background radiation, less than 4 minutes today. If you want to ask me about dark matter, about gravitational waves, about some new things that are happening in physics, there's been some big news articles over the last week about maybe 1-2 things, depending what you like. So yeah, ideally, if I could play my own music, I would play the music that was made specifically for the Cup of Cosmology trailer, because that's mine to play. But I haven't yet found a way to upload my own music. I can just play one of their like 4 default tracks, and I tried them all out, and none of them were great. So for now, we just have this like nice elevator music until I figure out more music there. So I see we already have some questions and a comment from David Dunn that my hair got lighter. Yes, this is not the effect of the sun. This is the sun did make it lighter, but it changed color this morning as well. It does that sometimes. It actually worked this time. Okay, comment from Scott. I saw the Oppenheimer movie. Is that out in Europe? Did you see it? Yes, it's out. No, I haven't seen it. I'm actually honestly a lot more keen on watching Barbie than on watching Oppenheimer. I was considering doing Barbenheimer and watching both because why not? But the problem with Oppenheimer is it's 3 hours long, and I like watching films that help me escape reality. I don't necessarily feel like I'm in the mood for 3 hours of a bunch of men talking about building a nuclear weapon. Like, I get that it's a good film and it's about the consequences. I feel like there's some things I know they've overlooked, so not really keen on that. But yeah, I'm unlikely to watch Oppenheimer, but I will at some point be going to watch Barbie, because why on earth not? It looks amazing. Every clip I'm seeing about Barbie is great. It seems very much like the kind of thing I would love to watch. I'm not yet sure if I have a pink enough outfit, so I might, because everyone I know is going to Barbie in like pink outfits. I don't have a pink outfit, but I could pull off a Ken much easier than I could pull off a Barbie. So, in the event that I do go watch Barbie, I might go dressed as Ken. Maybe, we'll see. But anyway, I'm not planning on watching Oppenheimer. I think Barbenheimer was great, but I definitely can't manage 5.5 hours of movie time on one day. So yeah, out of the two, I will be watching Barbie. It didn't feel like 3 hours. It had a who's who of 20th century physicists, yes. And I've heard that the first time a woman speaks in the film is 20 minutes in a sex scene. So yeah. Anyway, not overly keen to go see Oppenheimer, but I will definitely be watching Barbie. Happy to watch that twice, like watch it now and watch it again in 3 weeks. But yes, definitely going to be watching Barbie before I see Oppenheimer. But yeah, it's fun asking in the office like who's seen what, because there's half of my group have seen Oppenheimer, some people have seen Barbie, some have seen both. And it's quite fun because you just ask the question, who's done Barbenheimer? And then you get a mix of answers. So it's always fun. Okay, so I see there's non-Barbie and Oppenheimer questions and comments about Barbie and Oppenheimer as well. So let me just get through the comments, the topical comments, and then we can go through everything else. Hey, James, great to see you as well. Just saw that you started posting here as well. That didn't feel like 3 hours. Yes, okay. Long movies, great value for expensive ticket. Yeah. Yeah, they came out on the same day, and it's the first time in like 10 years that there have been 2 films targeting adults that have come out at the same day in cinemas. It actually became a big thing. Like people were trying to pit them against each other, and then they decided, no, just watch both. And now there's actually a Wikipedia page on Barbenheimer. So it's always nice to see when memes become reality. Not all memes, but sometimes. Okay, so what are the implications of the universe being twice as old as predicted earlier? I knew somebody was going to ask that, and let me see if that's the same question that's been asked later on as well. Seen that. Okay. Astronomers find a galaxy without dark matter that questions the standard model. Okay, so we have some good questions. So, galaxies and what it means. Let's start with that. And Barbenheimer, can you watch both at the same time? Oppie would have to be 2 times speed sync up. Yeah, I'm not sure if you'd like have one in each ear, how that would work, like split vision, not sure. 3 a.m. screening for Oppenheimer. Wow. Well, that's dedication. Right. So, is the universe twice as the age we expected it to be? Short answer, no, it's not. But let's unpack this claim. So there's been a very big claim recently that the universe is actually not 13.82 billion years old, but is about 26 point something billion years old. This is a huge claim. This is saying that everything we thought we knew about cosmology is wrong. Big claims require big evidence. If you're going to make a huge claim like this, it does require some stuff to back it up. So there was one group of physicists who put out a paper claiming that the universe is twice the age we thought it was. There's also recently been JWST images with galaxies that look slightly older. This is unconnected. But this new paper uses data in a way that seems a bit odd. Like they're basically saying everybody else has done this wrong. Here's how you actually do it. But they're not doing it in a way that makes physical sense. The sex scene was not the first spoken dialogue by a woman, but it did surprise me. Okay, yes. Anyway, Oppenheimer not on my list. Not anytime soon. So yeah. This idea of tired light, right? What this paper claims is that light basically gets tired so that then it changes the speed at which it travels. And this changes how everything happens in the universe. So okay, yeah, that's a big claim. But then I've seen a lot of people saying like, okay, these people use our data in a way that we don't intend the data to be used and without substantiating anything. So now this paper has passed peer review. This is always important to mention. This paper has passed peer review, but peer review is often one person peer reviewing. So while peer review does often work, not everything that has passed peer review is scientific fact. Now, this paper claiming that the universe is twice the age we thought it would be is very, very interesting, but I would say definitely so a lot of caution before, like, read it with a heavy dose of caution, because it does go against a lot of what we believe, and a lot of people working on, or not what we believe, a lot of what we've been doing. It's basically saying everything every cosmologist has been doing for the last 30 years is wrong. Here's why you should be doing it this other way, and then not backing it up. So everyone I know who works in the field does not take this paper as a credible claim. Now, the problem is this paper was picked up by a lot of newspapers, and a lot of places were talking about, okay, the tired light universe is twice the age we expected. And then it got hyped up even more. And this is a story that can be used as like a story about the perils of using artificial intelligence and machine learning to gauge your answers. So now, if you ask Google a question, you get the common answer. And up until a few weeks ago or a few days ago, if you ask Google how old is the universe, the first answer you'd see is 13.82 billion years. Great. But then enough science magazines were talking about this tired light universe is 26 billion years old, that then if you ask Google how old is the universe, the first answer you would see is 26 billion years old, because it was pulling from like what's current now. And it didn't come with a disclaimer of like, this is contentious, this is not what people believe, this is like one group, this is an outlier. It was just like, you ask Google age of the universe and it tells you 26 point something billion years. Now, this is a huge problem, because we trust our search engines. We shouldn't, but we always assume that our search engines are being reliable. And if you ask your search engine a scientific question and it gives you a wrong answer without any disclaimers, this is a huge problem. And a lot of scientists complained about this, and then it's actually been changed back now. And now if you ask Google the question again, you get the correct answer. But for about 2 days, Google was giving you the wrong answer, because it was just pulling from what is happening currently in the news, and then it was giving you the current answer that is not very well substantiated. So my thoughts are, take this claim with take this claim with a heavy dose of cynicism. When someone says everyone else in the field is doing something wrong, you have to ask, like, why? Okay, why is literally everyone else been doing something wrong? Sometimes there are groundbreaking results and things need to be changed and adapted. But this is something that I would like to see analyzed a bit more thoroughly before we start taking it seriously. But it would be very interesting. It would just mean that a lot of other things don't make sense, and then we'd have to reevaluate a lot of other things. So, tired light age of the universe being twice what we expected, probably don't worry about it too much. That would be my takeaway from that. But it is very cool that you all asked me about it, because it is a very timely question and it is a very relevant question. And I completely forgotten that happened in the last 2 weeks. So I completely forgot that you were all going to ask me about that today. So it's great that you did. I have like 3 things in mind that I thought you're going to ask me about this today, and that was not one of them. Oppenheimer was one of them. So there's 2 more, and I see one, they've both already been mentioned in the comments, so that's good. Okay, going through the comments again. Implications of the universe being twice as old as predicted? Probably none, but if it's true, it would be amazing. But we'll see. Okay, everyone is talking, in the States, everyone is talking about the congressional hearing on UFOs and aliens. Okay, yeah, let's talk about that one, because that was one of the other things that I was very much expecting people to ask me about. So there was a big thing in the US this week where somebody, member of somebody who worked for the US government, has done a whistleblower thing and has claimed that the US has evidence and actual pieces of spacecrafts and of aliens, like of non-human beings. So this has obviously gained a lot of attention because it's a big claim and it's a big thing to talk about. So just going back to how that was phrased, right? So there was this congressional hearing. So this guy came forward and said, okay, I have evidence of the government hiding aliens, and it went to a congressional hearing. And then the thing to bear in mind is that Okay, so his claims are that the US has been aware of alien activity probably dating back to the 1930s. They have recovered spacecrafts that have crashed to Earth, and they have recovered non human beings from said spacecrafts. Now, here's the thing, he does not claim to have seen any of this himself. Okay, so this is somebody who worked for the US government, who was tasked with analyzing UFO activity. But he has not seen any of this himself. He's saying that this is stuff that he's heard that other people have seen, and he's heard it from people who work on it. Which means he cannot present any real evidence, right? Because he doesn't have any. It's just people have told me. So that's the first thing. I have no doubt that this guy believes what he's saying. Like, I really have no doubt about that. But I don't believe what he's saying. Like, in anything like this, there are people involved who are not just the government, right? There's non-military people involved in things like this. There are probably scientists. If you're recovering an alien spaceship and trying to reverse engineer it, you're going to need scientists, you're going to need engineers. And one common thing all scientists have is we are ridiculously bad at keeping secrets, like ridiculously bad at it. One guy is a former intelligence officer, and one or both of the others are pilots, yes. So, if the US government was hiding evidence of aliens, some engineer, some scientist working on this would have slipped up, because we are terrible at keeping secrets. This is why I think conspiracy theories that involve scientists lying just make no sense, because if you've got something that would reshape the way humanity views the universe, you're not going to keep it to yourself. Maybe the US government would, but the people involved would not. So I don't think there is this big conspiracy, this big cover up. I think it's a series of things that have filtered out that said that, I would not take it too seriously. We don't have any evidence for aliens having visited us. We don't have any evidence that aliens have technology to visit us. We don't even have any evidence that aliens exist at all, anywhere in the universe, let alone a species with interstellar travel capable of visiting us and that has actually visited us. So I would take any claims of UFO activity with a serious dose of cynicism again. I'm being very cynical today. Given the record of government in nearly every endeavor, the idea they could orchestrate a massive conspiracy over decades is vastly implausible. Yes, right. It's something that would still be there when you change government, when you change parties, when you change political environment, and the idea that there's a secret lingering behind everything is just, it seems implausible to me. And we don't have any reason to believe that aliens have visited us. There's no evidence to support this. The universe is vast and mysterious and crazy, and we don't understand most of it. And it's quite likely, in my personal opinion time, not fact, it is quite likely that there are living beings out there in the universe, probably in the form of microorganisms. I hope that there is some other civilization out there in the universe, because else it's going to be a pretty lonely universe. But this is something we have zero evidence for. So it would be amazing if we were to contact another species, but it's just not something we have any evidence to support. So I get that a lot of people in the US were excited about this, and a lot of people are like, wow, we found evidence, but yeah, we really haven't, unfortunately. And saying I have evidence and my evidence is someone else told me, that's not evidence. That's not proof of anything. That's someone told me. We can all play this game of whispers, right, where you pass information along and see how bad it gets by the end. So yeah, there's also this thing, as Scott is just saying here, like, why do people always assume that aliens would be bipeds that look almost human-like? It's a big assumption. They're already the assumption that there's aliens and that they can reach us. But then why would they look anything like humans is baffling. And back in the HAPS days, we did a stream with all the HAPS scientists about sci-fi and stuff. And one thing we talked about was what alien life forms could look like. And why would they look like humans? There's no reason to assume that. Of course, they do in like every sci-fi show because it's easier, but why would they? And Mito saying here, there is a conspiracy theory that Finland doesn't exist. I've heard that. It's very funny. There's also a city in Germany, Bielefeld, that it's now an ongoing joke that anytime you meet someone from Bielefeld, you make the comment like, oh, but Bielefeld doesn't exist. And it started because like one map left it out once. And then from there, people were like, wow, the city doesn't exist. And it's become this whole joke that like there's this big city in the center of Germany that just doesn't exist, even though, you know, I've been there, people have been there, people live there. You can drive there, but there's still this idea. So yeah, claims of aliens, again, big claims require big evidence, and the evidence just isn't there. So yeah, I think it's interesting, it's exciting. It was also curious to see that for a lot of people, this didn't even register, and people were making jokes like humanity is just so done with everything that we're not even registering that somebody is announcing aliens. Like, you don't believe that I've been to Bielefeld, right? Yeah, Bielefeld, it doesn't exist. There is literally a video of me on YouTube doing a science slam in Bielefeld. But no, Bielefeld doesn't exist. That's fine. It's just this random thing, and it became such a big joke that now it's just so funny when you say like Bielefeld, no, that place doesn't exist. But yeah, some people think Finland doesn't exist. I can confirm that Finland does indeed exist. And Finland is an amazing place to be. But yeah, it doesn't exist now. How can you go there, right? Exactly, it doesn't exist. How can I be in a place that doesn't exist? Maybe it does. So yeah, again, big claims require big evidence. We don't have any evidence for aliens yet. And the day we do, I'm pretty sure scientists are not going to be able to keep this quiet. It will slip out. Galaxy Quest dealt with this by having the aliens look like octopeds, but using technology that makes them appear human. You know, that does work as well. There are always ways you can get around it, right? You can do like the alien chose this form to communicate with us, sure. But there's no reason to assume that aliens would have any interest in visiting us at all. And this is also the other thing, right? Before we don't yet have capacity to just fly out there into the universe, but we have sent signals. We have sent radio signals. So if aliens were going to visit us, would they just like spin by without sending anything like a signal first? So surely before looking for spacecrafts and little green men, maybe we should be looking for alien signals in like radio telescopes with different bands of the electromagnetic frequency. We haven't found anything yet. Oh, there's a wow signal that is confusing, but we haven't found anything yet. So that's the thing. I think it's always quite unlikely. I find it quite unlikely and quite hard to believe when people are like, oh, aliens have visited us. Like, why? Why would they do that? Why wouldn't we know about this already? You know, there's just so many things that make this implausible to me. I just try to figure out what our universe is. Hi, and I'm back to being blown away in a philosophical way. Yeah, what our universe is in. Sorry, I misread that. What our universe is in. Our universe is not in anything. Everything is in the universe. The universe is just there. The problem is if you start thinking about the universe being in something that involves an outside, but you can't have an outside of the universe because that will put an edge to it. And by definition, the universe is everything in existence. But yeah, it's kind of weird because we're used to imagining things in a place, but the universe isn't in a place. The universe is the place. The universe is everything. So yeah, I agree. It gets very philosophical and very deep when you start thinking like, but what is the universe? What is the universe inside of? And it's a question we can't really answer, but it's a very, very cool question. I highly recommend the Carl Sagan movie Contact starring Jodie Foster. Yes, that is a very good one to watch. I think Arrival I also really enjoyed in terms of like alien communication. Arrival was done really nicely. There are some very good sci-fi films that do elaborate on different life forms, and it's very cool. But it is all speculation. The universe is the place to be. It is. No place like it. Love the aliens description in Childhood's End. Not spoiling anything, but it's very clever and tied into the story. Nice. I have not read that one. I will add that to my list of things to read. So yeah, I get that we want to find aliens, and it would be really cool if we do find another species in the universe. But I think long before we find a spacecraft with pilots from another planet, what we're more likely to find is microscopic life forms somewhere within the solar system, like one of Saturn's moons, one of Jupiter's moons. Then we'll find like traces of, maybe eventually we'll find traces that there were life forms on other planets. And then maybe at some point we'll progress to finding different types. It's going to be gradual. I don't think the first thing is that we're going to find is going to be a fully formed cogent alien who's coming to chat to us in a spacecraft. I think there's a lot of milestones we're going to reach before that stage. But maybe I'll be proven wrong, and tomorrow a spaceship will descend, and it will be so clear that we can't deny it. But we're not there yet. Okay, going back through the questions, we talked about music, we talked about UFO, we talked about Barbenheimer. Yes, astronomers find galaxy without dark matter. That was the other one, galaxy without dark matter. So I feel like this headline comes along very frequently. There are frequently things of galaxies without dark matter. So let me just catch up on the comments here. We study all the life we can find. Why wouldn't they observe us with the same curiosity? Plus, I could see why they wouldn't want to talk to us just yet. Yeah, but then, if they can see us, we can probably see them. It goes back and forth. Oh, astronomy picture of the day on the 15th of July presents fine gravitational lensing in JWST deep field image. That's nice. The airport pictures are always really cool to look at. The aliens do not want to speak to our kind. Yeah. I don't know. Maybe they've decided we're not worthy of being spoken to. Okay, galaxy without dark matter. I feel like this claim comes about every 6 months or so. Scientists find galaxy without dark matter. And okay, this is cool. The problem is we don't understand dark matter as it is, right? We're pretty sure that every galaxy has dark matter. We're pretty sure that galaxy is literally the glue holding dark matter. Sorry, that dark matter is the glue holding galaxies together. Without dark matter, galaxies would kind of be flung apart. We haven't found a way to have galaxies without some amount of dark matter. But there could be some, like very early galaxies that are formed in a different way that don't have enough speed to throw out their stars so they could still hold together and not have dark matter. It's not something we expect to find a lot of, but it feels like every 6 months or so there's a claim of like, oh, we found a new galaxy without dark matter. And it's cool and it's interesting, but it doesn't refute dark matter. We don't understand how dark matter behaves. We're still trying to figure that out. The stuff we know about dark matter is it's invisible. It interacts via the gravitational force, and it's pretty much everywhere we look for in the universe where there's normal mass. And that's everything we know about dark matter. We know it can't be too small, can't be too big, but otherwise, it could be a lot of things. So when people say we found a galaxy without dark matter, I'm like, okay, first of all, how did you find this? And then the answer would be, okay, you can, if you do some gravitational lensing to see where all the mass is, it matches the mass that we can visibly see. Okay, does this account for some stars being brighter than others for different luminosity effects? I feel like there's a lot that goes into this. And I'm always very curious, but slightly skeptical about these claims of galaxies without dark matter. And even if they do exist, it doesn't mean that dark matter doesn't exist. It means that, okay, we found an outlier, we found something that maybe doesn't fit our standard model of dark matter. But there's a lot of things that don't fit our standard model of dark matter by now. Like, it's the fact that we haven't found it yet. What if dark matter is just a fifth fundamental force that's only observable on galactic scales? But then how would this work, right? Why would we have a force that only works on specific scales but not on other scales? And the thing is, if it is a fifth force that only works on galactic scales, how do you explain the cosmic microwave background radiation? This is the thing. This is the afterglow of the Big Bang. This is the oldest light we have in the universe. It comes from 380,000 years after the Big Bang, after the end of inflation. What you can see here, the orange and the blue, these are hot photons and cold photons. And everything here points to a universe that has dark matter. We have not been able to explain these orange and red spots, these hot and cold spots, without dark matter. Believe me, we have tried. There have been hundreds of proposals against dark matter. And this is the thing. Do you think scientists like having a big chunk of the universe that we don't understand? Like, we would be happy if there was a simple explanation for dark matter, but there just none of that has worked. We keep trying, it doesn't work. Dark matter could be a fifth force, maybe, but then you can't explain the CMB. Dark energy being a fifth force is up for debate as well. But this is the thing, we keep trying to find the explanations for dark matter, and nothing we found yet has worked. Nothing can explain the cosmic microwave background radiation, this amazing map we have of the baby universe. Nothing can explain that as accurately as the picture of a universe with dark matter and dark energy. So then it becomes the thing, like, until we have, even if this is not the best explanation, it's the best we have so far. And until we find a better one, we stick with dark matter. So yeah, people claim they found a galaxy without dark matter. That might be. And that's something else we have to explain and something else we have to understand. And it's really cool and it's really interesting when this happens. But yeah, it's interesting. And people often use this as like, oh, this proves dark matter is wrong. Well, it proves that dark matter is weird and funky, and we don't understand it, and we're still trying to figure things out. The universe is crazy and confusing and weird, and we don't understand most of it. Yeah, so this is the thing, as James is saying, we have examples where the gravitational force of the visible matter is enough without dark matter, and this is the thing, people are claiming yes, we do. It's interesting because then it's just another puzzle piece that we need to fit together, and every time we get more data that helps us get one step closer to understanding dark matter, it's cool. So yeah, it's very interesting. We found potentially another galaxy that doesn't have dark matter. It's very interesting. I'm curious how they found this. I'm curious who found it, but it would be interesting, and it's just another puzzle piece that we have to solve someday, hopefully. What if the CMB roughness is proof of quantum foam in the epoch when the radiation was made? I'm not sure how you would get a CMB with quantum foam alone. So the idea here being that you have normal matter, radiation, obviously part of normal matter, and some quantum foam. Yeah, then you would also need something to explain the galaxies, or do you want quantum foam for the galaxies and quantum foam for the CMB and a fifth force for the galaxies, right? Because then it becomes the idea of, if you need 3 or 4 things together to explain the evidence when you have one thing that does it all, why would you go for the 3 or 4? But I'm not completely sure about this idea of quantum foam being able to explain the CMB. If you do have a reference for that or some things you've read about that, feel free to share it with me, because I'm not completely sure how you get the CMB from quantum foam, but it does sound like a cool idea. But yeah, if you want something to do with the CMB, the galaxies, the overall structure of matter in the universe, nothing comes close quite like dark matter. Again, nothing yet. Maybe we'll be proven wrong. I would love to be proven wrong. It would be really funny if I spend my career working on dark matter and then someone's like, actually, dark matter doesn't exist. Here's proof. That would be really cool, right? I mean, it would be a bit frustrating, but also very cool. Ideally, I would be the one to do that. Like, ha ha ha, had enough of dark matter. But yeah, it would be very cool. So I like it when there's things like this that challenge the idea of dark matter, because then we get to poke about things a bit more. But yeah, until we find something that works as good or better than dark matter, that's what we stick with. And yes, I did indeed show the CMB before 4 minutes in. I started with the CMB today. Again, it is in the logo, but I know you people think that doesn't count, but it technically does. Okay, going back, I know there were some very cool questions quite early on that I missed. So I'm just going back through everything. Large old galaxies and lots of theories about what it might mean. Yet tired light did that. Okay, going through the comments, because I know there were some questions that I missed there. So just making a note of one here that I'm going to get to, and then I'll go through the rest of the questions and see what else there is. A comment from Paul before: if you use ChatGPT that way, I am under no illusion that I should trust it. Yeah, do not trust anything ChatGPT tells you. See, the thing about ChatGPT, I saw this comment earlier and was like, I'm not going to go there. But the thing about ChatGPT is it does not answer questions. What it gives is, this is what a plausible answer to this question would sound like. And that is an entirely different thing. Because when you ask it, like, tell me what color the sky is, ChatGPT doesn't know that the sky is blue. It's like, what is the most common answer to this question? Okay, here it is. So then if you ask ChatGPT, like, write me a paper that seems like a scientific paper, it will pull together a bunch of bullshit and invent references and say, this is what a paper on this topic might look like. But it is not telling you, here is a paper on this topic. And I think one of the biggest issues is that people think it's giving answers, and it's not giving answers. It's giving, here is what a plausible answer to your question might sound like. And that is a big distinction. And we need to treat it as that, and not as, this is giving me answers, because it's not giving you answers. It's giving you a pretend answer. And people who take ChatGPT seriously will be lied to, because ChatGPT is not a truth machine. It is a glorified chat predictor. Anyway, rant about that over. Going back through the comments, there is the one about the superconductors that I know I want to get to. But just checking that there's nothing else, because the superconductor one is going to be a fun one to answer. Just going through, checking all of those, giving you all a chance to think of your next questions as well. Okay, I think apart from that one, that was all of them. I always pack my quantum mechanics in quantum foam. Yeah, always pack quantum foam with you. You people. Did I make a comment about you people? Yeah, I probably did, actually. It's never meant despectively or in a disrespectful way. I use people to like refer to everybody. Okay, more about quantum foam. Let's see, quantum foam. That's a very nice comment from you there, Guadav. Thank you. No questions. Just want to tell you all to treat yourself often. Be easy on yourself. Often we are too hard. That is really nice. You know, we are often too hard on ourselves. We are often we don't give ourselves the grace we would give others. And you know, we need to remember to take care of ourselves as we take care of each other. Quantum foam for specifically the temperature difference in the CMB, radiation passing through different densities of the foam, resulting in different temperature detection. So quantum foam is usually invoked in the very, very, very early universe if you have something like the multiverse. Now, by the time of the CMB decoupling, the universe has expanded enough that quantum effects are no longer the dominant effect there. So if you do have some type of quantum foam, it's a very tiny, tiny quantum-sized concept, which might make sense in a very, very early universe when the universe was tiny. But by the time, or substantially smaller than it is now, still infinite, but smaller infinite, makes sense somehow. But if you want quantum foam to still be playing a role at the time of the CMB, it's quite hard because you have a size issue, right? Because quantum foam wouldn't really play a big role once things are spread away and decoupled and broken out. So if you want to set the conditions like at inflation or before inflation, can't really talk about before inflation, but like the initial conditions for inflation, then you can talk about quantum foam. But I'm not sure how you would be able to put quantum foam into a later stage universe like the CMB. And it's quite funny because I used to call the CMB early universe, and now that I work on stuff on the first picosecond, like a fraction of a fraction of a fraction of a second after the end of inflation, CMB is late universe for me. I've started referring to the CMB as late universe, and every time I do, I feel like I've betrayed past me. But yeah, depends what you define as early and late, right? I often say you people because I'm an alien. Yeah, I often say you people honestly because I used to always say you guys and realize it was unnecessarily gendered. And then I switched to saying you folks and realized that it doesn't come naturally to me to say you folks. So I just switched to you people, like you people in general, whatever, however you want to refer to yourself, people. It's easier. Did you miss a class? New word, quantum foam. No, so quantum foam is not something that we know as being like an actual thing, but it's a hypothetical thing that people think of when talking about multiverse and the universe and like this cosmic landscape. So you can have quantum foam, or hypothetically, and it's something that is fun to play about with. But yes, it's not something you need to think about as being like, oh, there's quantum foam everywhere. Maybe. CMB is toddler universe. Well, yeah, it's baby universe. You people is in the southern US, you say y'all. Yeah, I try saying y'all. Doesn't work for me. Y'all, I just can't do the y'all properly. No, doesn't work for me. What is the difference between string theory and superstring theory, and what's the significance of 26? No idea. String theory is an idea of a model of quantum gravity that tries to explain how you can unite the quantum world and the gravitational world. And it is a very elegant mathematical description that unfortunately doesn't seem to apply to our universe. And superstring theory is taking string theory and making it super saiyan. No, sorry. Superstring theory is, I'm not sure, but I would guess it's adding a supersymmetric particle to string theory. I'm not completely sure. And the significance of 26, it's something that probably pops out of an equation and you go with that. I'm not a string theory person. When you think of the first picosecond, are you thinking quantum at that point? Excellent, excellent, excellent question. And yes, if we are talking about after inflation, but we are talking about quantum fields. So a field is something that permeates all this, is everywhere in the universe. A quantum field is a field that permeates everything in the universe and gives particles properties. Yeah. Yes, when we're talking about picosecond, we do need to talk about quantum stuff. And the type of stuff I'm interested in is if you have, like when you heat water and it bubbles and boils and you get these little bubbles of gas and then of vapor and stuff like that, but in a very early universe. And there we do have many, many quantum effects to be aware of. Standard English is lacking a good second person plural pronoun. It is, it really is. I guess we could go back to doing like thy can ask me questions. Like it just doesn't work. But yeah, y'all doesn't work for me. You folks doesn't work for me. So I use you people because then it's also like you people, us people, we're all people here. I think, right? So people just seems like the easiest one to default on. That is not gendered. So that's the one I've defaulted on. Okay, so I mentioned before that there were 3 things I was expecting people to ask me today. Oppenheimer, we covered that very quickly. The aliens hearing, yes, we covered that. You mentioned light getting tired. Isn't this expected since it's a wave? Shouldn't it flatten out over time? No, light carries all of its energy with it. So it gradually gets redshifted, right? It gradually stretches, but it doesn't slow down. It doesn't get tired because it's not a beam of energy. It's a particle. So it doesn't, we don't expect light to get tired. This is this new idea that people have had, or not a new idea, it's an old idea that people have brought back, that light could get tired and gradually drag and change the speed at which it's traveling today with respect to the speed at which it was traveling in the early universe. And if you do this and do some funky stuff, you get age of the universe double what it is. But that doesn't seem to be the case. We don't expect light to get tired. Okay, had a picosecond last night in the sense of second helping of pico de gallo. Approve of that. Always go back to second helping. Oddly, you was the formal and plural form. English lost the informal thou. Thou shall not ask me questions. Thou shall ask me questions. Yes. Okay. So I said there were 3 things I was expecting to be asked. We covered Oppenheimer. We covered aliens. Okay. And the 3rd thing I was expecting to ask, and it was asked quite early on, and I've ignored it until now, was if I can comment on the superconductor. And I absolutely can and absolutely will. So, bit of context. What is a superconductor? A superconductor is a metal that conducts electrons almost with no resistance. So any metal is like a mesh of atoms, right? It's a mesh of atoms, and electrons can move through this. Now, when you're creating an electric current, what you're doing is you're sending electrons through a metal. Then the electrons travel through the metal and you get your electric current. Depending how it's moving, you create a magnetic field as well, because electromagnetic field, electricity and magnetism are 2 sides of the same coin. We call it electromagnetic field. Now, in any metal, there is resistance. Based on the way the atoms are positioned, the electrons can't travel completely freely. They're going to meet resistance. This resistance means that you don't get perfect transmission of electrons, right? You get them slowing down. A superconductor is a metal that has basically no resistance. Electrons can just travel through. The way it happens is it ties electrons together, and then they don't feel the vibrations of the metal, so they can just kind of go through it. Put simply, it's a very, very, very complicated topic, and not something I've worked on since my undergrad when I had to learn these things, but it's not something I've worked on ever, and it's quite far away from cosmology. But it is incredibly cool, literally, because superconductors have a huge amount of applications. Superconductors, if you've ever had an MRI, that magnetic field is powered by a superconductor, because one nice application of superconductors is you can generate a magnetic field with practically no energy investment and no energy loss. So you can create really strong magnetic fields without too many of the problems. So MRI machines are aligned with superconductive metals. If you want something like a magnetic train that levitates, like one of those levitating trains that can reach ridiculously fast speeds, superconductors are the way to go. It has a huge amount of applications. Now, there's problems with superconductors. We've only been ever, we make superconductors by doing two things. We either put the metal at really, really, really low temperatures, almost absolute zero, so like minus 273 Celsius, minus 444 Kelvin. Sorry, Fahrenheit, 0 Kelvin, minus 440 Fahrenheit, about minus 273 Celsius. And at this temperature, a lot of metals become, not a lot, but some metals become superconductors. It's kind of like the atoms get too cold to vibrate, and then the electrons combine together and pass through them. So for a superconductor, you need low temperature, or you need a different amount of pressure. You can change the pressure on the metal, and that changes the way the electrons go through it. So usually you change both temperature and pressure, ideally one or the other. What people are trying, obviously cooling something down to this temperature requires a lot of energy, which is why superconductors are something that, would be great if we could have them at room temperature or at an easier temperature. So there's been a lot of effort over the years to try to get superconductors that work at higher temperatures. And it's always very, very, very difficult. There have been some claims in the past of metals that are superconductors at approximately room temperature or a couple of degrees maybe, but then they need a ridiculous amount of pressure, or vice versa. Often these claims turn out to not be reproducible. So here's the exciting thing. Big news dropped this week. A team in South Korea, put out 2 papers. These have not passed peer review. They are preprints. They have not passed any type of peer review. And in these 2 papers, they claim that they have a superconductor that works at room temperature and at room pressure, meaning you could literally just build one and have it sat on your desk and it would be a superconductor. This is a massive, massive, massive claim. And if true, this is a huge discovery. This is a key milestone for physicists. This could bring on another technological revolution, right? This is an incredible achievement if it's true. And this is a big if. So immediately when this came out, of course, people were like, I think black hole singularities have a temperature of minus 444. Yeah, what is it about minus 440 is the CMB. And that's like 3 degrees Celsius. Sorry, 3 degree Kelvin. So I just kind of subtracted like about 440, but it's in that general area. So immediately when these papers came out, these 2 papers, there was a lot of skepticism. There was a huge amount of skepticism because this is a very, very, very bold claim. So the type of criticisms that seem to be going around, again, I am not an expert on this topic. I'm just conveying what I've seen, what I've discussed with people, what I've heard. But this is not me presenting evidence of anything. Right? So the 2 authors in question are not well known in the field of superconductors. It's not something that they are known for. It's not something they have worked on extensively and published on extensively. Of course, that doesn't say anything. It could just be that they got lucky. The superconductor doesn't require 10 atmosphere of pressure. No, it works at room temp. They claim that it works at room temperature and room pressure. Like, it just works, which is, again, a bold claim, but amazing if true. So, of course, the fact that they're not well-known experts on the topic doesn't mean anything. The paper itself is quite difficult to parse. The way it's written, now I've seen comments going around that it was at least co-written by ChatGPT. I don't have any evidence to back that up. That's just a claim I've heard. But the way it's written, it refers to papers that have been discredited. It doesn't like build up the background of superconductors. It feels like the paper was written by people who do not know about superconductors, right? So this is something else that people are like, okay. Then it seems like a lot of key data, the way the data is presented is not how people usually present this type of data. So that makes it quite hard to compare to other things. And like some key plots that you would expect to see in a paper claiming superconductors are missing. But the cool thing is, so the metal that they're using is basically lead that has been infused with copper and a few others, like so lead and copper. They are aliens on Earth helping us humans out again, yeah. So lead and copper, which doesn't actually make sense according to people who work on superconductors. Like, why does this work? But it could just be that this is the perfect combination of metals in the right amount of quantities that just hits a sweet spot. And the cool thing is, this is something that takes about a week to build. Right? This metal that they've claimed as a superconductor, it is easy to reproduce. Like, not something I can do in an afternoon, but it's something that 4 or 5 days in a lab, you can build this. So if this claim is true, we'll know within a week. Like, literally, people are already building this to test it out themselves. A bunch of labs across the world are like, well, let me go see if I can do this. People are trying, people are testing it. There's a lot of skepticism around these papers, but people are testing it. This is something that is very, very, very easy to test. We don't need to wait 20 years for the next experiment. They're literally building it today. I'm expecting that within the next 4 or 5 days, this is either going to be falsified. Yes, copper is diamagnetic. Exactly. That is something that people are saying. Like, huh? Copper and lead? Really? But within the next 4 or 5 days, people will either reproduce this or falsify it. Right? This is something that is a short-lived claim. Now there's also, academics, every discipline and everyone has gossip and rumors and infighting and usual human behavior stuff. Academia is no different. So there are already rumors and stuff circulating that apparently there's some issues with the papers, not the papers themselves, but the process behind them. It seems like some of the authors had some disagreements. One of the authors has said that one of the 2 papers was put online without his permission. Then at some point, another one of the authors gave a talk on this topic and credited a university that then said, no, we don't want to be associated with this. So there seems to be some weird stuff happening behind the scenes, but none of that matters, right? It will be a footnote in the story. This is an incredible claim. So what are the implications if it works? If it works, we can start manufacturing superconductors easily. It will be a cheap and easy way of having clean energy movement. Like, not clean energy, but clear movement of electrons. So type of applications could be levitating trains, technological advance. Like, it's quite hard to imagine everything we could do with this, but an MRI machine is ridiculously expensive to build. It's ridiculously expensive to run, partly because you have to cool it down. Imagine if you could run that at a fraction of the cost because you don't have to cool it down anymore. Or building it at a fraction of the cost because the materials are just readily available, it will go from being something that you use in extreme conditions, faster CPU, for an example. You just be able to move electrons faster. You could do things faster, and it could be amazing. I've seen people who work in cosmology very far away from superconductors, and we're all kind of really excited about this because, if true, this goes down in the physics history books. If true, like this is a huge claim. This is not something of like incidentally I found something. Like this is a big thing. This is the Nobel Prize winning thing. If true, again, if true, and it's really cool because we will know in a matter of days. People are already working on it. I expect by next weekend we'll know the answer to this. So next cup of cosmology, I'll talk about this again, and by then people should have had time to build it and test it and see if they can do it themselves. So whatever's happening, whether these people were experts or not, whether the paper is well written or not, whether there's infighting or stuff by like that doesn't matter. Their claims are scientific, and that's what we need to focus on. And it's something that we can and will be testing pretty soon. I say we, not me personally. This is nothing to do with me in any way. It is not cosmology. But it has so many applications that it could be really a really important moment in physics if proven, if we can test it. Why would scientists risk their career on something that could be easily disproved? Yes, that is a great question. But then there's also the thing of like, why didn't they do a big press release? They just put the papers out. Like there wasn't a big press release. There wasn't an embargo, wait until it's published in a journal and then do it a massive hit, it's past peer review. It's just kind of like, yeah. And now there's a thing that people are saying, like, actually, these papers weren't ready to be published. Maybe it was rushed. Maybe there were some issues. But why would they make this claim that can be falsified if it's going to be falsified in a matter of days? Do they believe it themselves? Is it something that they're sure? Like, yeah. And the thing is, there have been so many times that stuff like this has happened. As Ben is just saying, like when people found room temperature fusion. No, it doesn't work like that. Sorry. So yeah, Godav is saying here levitation is an example. Yeah, levitation is a very clear application of superconductors. I could have medical applications, it would have technological applications, information, like making computers better. It would be really cool. But again, it needs to be confirmed. The paper needs to pass peer review. There's a lot of next steps. But I feel like this is something that is short time scale. Like sometimes you get big announcements, like the Edges anomaly. We found some weird stuff happening in the early universe, and it's like, okay, give us 10 years to build a detector and we'll try to reproduce it. This is something that we might be able to test very, very soon. We should be able to test very soon. Reminds me when they thought they found faster than light particles. Yeah, that was so fun. To be fair, so there was a big thing a few years ago that the Oppenheimer team in Italy had found faster than light neutrinos. So neutrinos traveling faster than the speed of light. To be fair, they did not believe their results either. And they did a bunch of tests. They could not find what was wrong. And when they published it, they didn't publish it as like, we found faster than light neutrinos. They published it as like, we haven't found any other explanation. And then people immediately figured out that there were, or not immediately, but then they found that there was a faulty cable that was sending bad signals in the detector. Whoops. So yeah, sometimes it happens that there are big claims. A couple of years previously, there was the bicep one where they found early universe gravitational waves and proof of inflation, and it turned out to be dust. Bad luck. Apparently, one of the papers has 3 authors because that's the limit on how many people can share a Nobel Prize. Yeah. This is the thing. There's a lot of talk in the background of what's happening behind the scenes. But what matters is, can we reproduce this? And we should know within a matter of days if we can reproduce this. And if so, it's going to be pretty big, right? So it's something, definitely pay attention to this. Look out for the announcements, because it might be a big week for physics. It might be nothing. It might be that we're just like, nah, okay, nobody can reproduce it, moving on. It might be a step in the right direction. In any case, it's exciting and it's interesting. And we've been talking about this a lot this week in different coffee breaks and different conversations. It's something that we're all like, did they really? Because it's a nice day for science when stuff like this happens. And I'm really, really, really hoping, and I think a lot of people are really hoping that this is true, that we can reproduce this, because it would be really cool if that's the case. So yeah, a lot of us are really interested in this, and it's something to pay attention to. And I was sure somebody was going to ask me about this, which is why I read up about superconductors today, because everything I know about superconductors is like buried in my undergrad notes somewhere, lost in the back of my brain. So I read up about them today because I was hoping somebody would ask. So yeah, it's exciting. Whatever happens, it's honestly worth being excited about. And if they reproduce it, it's going to be amazing. We'll see. We'll see within a week. So be sure to tune in next week for Cup of Cosmology. Hopefully by then we'll have an update. And regardless of which way it goes, I hope to be able to talk to you about it all next week. So on that note, it's the end of the stream. We've been going for an hour now, so time to wrap up and wind down as always. We've had some really cool questions today, topics that I was fully expecting, topics that I was not expecting, but it's always fun. You've had some really cool questions. So thank you everyone for being here. I generally do appreciate you all coming in and listening to me ramble about cool stuff in the universe and in physics and asking me questions. Every week when I do these streams, there's the risk that people are not gonna chat, not going to engage, that I'm just going to be monologuing for an hour. And every week you come in with really cool questions, and it's always, always really, really fun. So thank you everyone for being here. It's been great fun. Yeah, it went by quickly today. There's a lot more we could talk about, but those were the main things that I was hoping to discuss at some point today. So thank you everyone for joining. It's been great fun. Cup of Cosmology should be online again, or will be online again next Sunday, same time as always. That's 7 p.m. in Europe, 1 p.m. if you're on the East Coast in the US, 10 a.m. if you're on the West Coast. As always, there is a time zone converter on cupofcosmology.com where you can get the next stream in your own time zone. Be sure to subscribe to the YouTube channel to get notifications about when I next go live. You should get a notification 30 minutes beforehand. So I'll be back next Sunday, same time as always. I hope to see you all then, and I hope in the meantime you'll stay safe and take care of each other.